Here we go again. Now I'm going to talk purely about the ClockDisplay class. This knows everything about the numberDisplay class. For example, it can call the numberDisplay's methods, like the increment method, or getValue, or getDisplayValue. Those are the three methods that exist in the numberDisplay class. So they have the increment, the getValue, which gives you an int, for example, to do math on. I'll talk about that in a minute. And getDisplayValue. This is the numberDisplay class on the left-hand side here. GetDisplayValue. Okay, so there's three methods over here. They're all public. And that means the ClockDisplay class, which is composed of numberDisplays, can call these things. Can ask its minutes, for example, hey, what value do you have? What value can I display? And please go up by 1. The ClockDisplay adds a bit of intelligence. For example, it puts a colon here for displaying. And it also does this. When the numberDisplay minutes value gets too high, for example, too high would be reaching its limit, which is 60 for this object. It goes from 59, and then I can call increment on my minutes. For example, it goes to 0. That's done by this guy. Now the clock is smart enough to go, well, if the minutes just went from 59 to 0, my hours just went up by 1. So the clock adds some intelligence. And the clock definitely makes use of the numberDisplay methods. The reverse is not true. The numberDisplay doesn't know anything at all about clocks. All it knows is it has a value, it goes up, 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 until it reaches its limit, then it rolls back down to 0. That's all it does. It does not know about days of the week, hours, minutes, AM, PM, nothing. It doesn't. For example, like I said, I can use this to keep track of people waiting in line at a delicatessen. Nothing clock-like about that. Or to keep track of my odometers in my car. The mileage goes up, 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 back to 0, up, 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 back to 0. And there's nothing at all to do with clocks. My ClockDisplay, therefore, it just needs two objects. A numberDisplay with its own limit and its own value for the minutes, and a numberDisplay with its own limit and its own value for the hours. And then I'm going to make other methods in here, like one of them is called timeTick, and in fact I would have called that something like minuteTick, because that's what it does. Every time you click this, or anytime you run this method, the clock gets advanced by 1 minute. I'll come back to that in 1 second. First of all, I've noted we should move around the ClockDisplay slides in the PowerPoint slide and look at them in this order. Slide 13, 24, 28, 29. So the ClockDisplay code is quite spread out. But I'm going to follow it in this order. 13. This is all I need. All I need are two instance variables, and they are not ints. A lazy person or an inexperienced person might say, all I need for minutes and hours are two ints. But then you're missing out all the additional functionality that our numberDisplay class gives us. For example, the rolling over. For example, the proper display of minutes with the leading 0. For example, 1:05 instead of 1:05. 1:09 instead of 1:09. If it's 1:09 p.m., The number display has the ability to append the leading 0 to numbers less than 10. 2 ints here would be horrible, because you'd have to do all kinds of logic all over the place to determine when they should roll over back to 0. My number display does that beautifully. Plus, later on when I need to make a delicatessen weighting number machine, all I need is one number display and I'm done. When I need to make an odometer system for my car or my bike or anything, all I need is a number display. So the reusability of this code will earn me a lot of money and save me a lot of time in testing problems. Slide 24, you can see that the authors of the book have added a totally unnecessary third instance variable. All I really need are these two. But every time you click a minute ahead, the authors have chosen to store the new time in a string. It's actually not a good idea. Don't worry about it. We need these two number displays, one for hours, one for minutes. Since this is a number display, we know that this thing knows how to increment. It knows how to get value. And it knows how to get display value. So does this. Every time I increment a minute, I should check, did I go all the way to 0? If I did, I better increment the hours. Does that make sense? If I just went from 59 to 0 in the minutes, I just changed my hour. 359 plus 1 minute goes to 40. So when I increment my time 1 minute at a time, I have to check the new value. Did I just hit a 0? That means I need to advance my hours. And I'll update my display string to show every time I advance a minute, it goes from 3:59 to 4:00. That's all this does. Puts a colon in there. When I create my clock display, I know already my maximum hours is 24. I'll never quite reach 24. When I do reach 24, it should roll over. And my limit for my minutes is 60. Go back and review the number display class constructor, and you'll see that when I create my clock this way, it is 0 hours and 0 minutes o'clock, because my number display constructor accepts parameters for the limit and sets the value to 0 for every number display. When I do advance this time tick, which means minute tick, it does just what I said before. It increments the minutes and then asks, hey, did I just go to 0? If I did, let's advance the hours. Notice I'm not using getDisplayValue, which returns me a string. This gives me an int, and I can do arithmetic on it, like compare